Hello everyone and welcome back to our course on creating a Magento 2 admin grid. In the previous lesson, we set up our database schema using Magento's declarative schema approach. Today, we'll be diving into lesson 3, Model and Resource Model. In this lesson, we'll learn how to create model, resource model, and collection classes, implement CRUD operations through a repository pattern, set up relationships with other entities if needed. These components form the foundation of how we'll interact with our database. Let's get started. Before we dive into the code, let's understand Magento 2's model architecture. Magento follows a specific pattern for database interactions. Model represents a single record and contains business logic. Resource model handles the actual database operations CRUD. Collection manages sets of models like retrieving multiple records. Repository provides a clean API for CRUD operations. This separation of concerns makes the code more maintainable and testable. This flowchart gives us a clearer view of how these components interact with each other. As you can see, both controllers and repositories work with models, while UI components typically interact with search criteria. The resource model serves as the connection point to the database, and collections enable us to work with multiple models at once. Let's now look at how these components relate specifically in our blog post module. Now, let's examine the specific relationships between our blog post classes. As you can see in this diagram, we have blog post interface, the contract that defines what methods our model must implement. Blog post, our main model class that implements the interface. Resource model blog post, the resource model that interacts with the database. Resource model / blog post / collection, the collection class that manages multiple models. These classes work together to provide a complete data access layer. This flowchart shows how these classes are connected. The blog post model implements the interface and uses the resource model. The collection references the resource model to perform its operations. This structured approach helps maintain clean separation of concerns. Let's start by creating our blog post model class. This class will represent a single blog post record and will contain getters and setters for each field in our database table. I'll navigate to our module and create a new file at model blog post PHP. Let me explain the key parts of this model. We extend abstract model, which provides basic model functionality. We implement our custom interface blog post interface. The underscore event prefix is used for dispatching events related to this model. In the underscore construct method, we initialize the model with our resource model. We provide getters and setters for each field in our database table. This model will be our main way of interacting with blog post data in our code. Now let's create our resource model. This class is responsible for the actual database operations. I'll create a new file at model / resource model / blog post PHP. The resource model is quite simple. We extend abstract.db, which provides database operation functionality. In the underscore construct method, we specify the table name itforo underscore blog post, the primary key column post underscore ID. This class will handle loading, saving, and deleting blog posts from the database. Next, we need a collection class to handle sets of blog posts. This is useful for retrieving multiple records at once, like we'll need for our admin grid. I'll create a new file at model / resource model / blog post / collection PHP. The collection class is also straightforward. 1. We extend abstract collection, which provides collection functionality. 2. In the underscore construct method, We initialize the collection with our model class blog post, our resource model class resource model. This collection will allow us to retrieve multiple blog posts, apply filters, sorting, and pagination, all essential for our admin grid. Now, let's implement the repository pattern, which is at the heart of Magento's service contracts architecture. The repository pattern separates the business logic from the data access layer, making our code more maintainable and testable. First, we'll create an interface at API/data/blog post interface. PHP to define the contract for our model. In Magento, all entity interfaces should be placed in the API-data directory to indicate they are part of the public API. This interface defines the contract that our blog post model must implement. It goes beyond just a simple structural blueprint. It's actually a crucial part of Magento's service contracts architecture. Let me explain why it's so important. Constants as field identifiers. We define constants for all database fields, which serves multiple purposes. Provides standardized access to field names throughout the codebase. Eliminates typos and string errors when referencing fields. Makes refactoring easier. Change the constant value in one place instead of searching for strings. Creates a self-documenting code pattern. Type-hinted methods. Notice how each method has PHP-doc comments specifying the expected parameter and return types. This is essential for API consistency and predictability, enabling static code analysis tools to catch type errors, supporting proper-eyed auto-completion, establishing a clear contract for implementations, self-returning methods. The setters return $this, allowing for method chaining like $blog post, setItLetitle, setContent, which creates more readable and concise code. Module boundary. By placing this in the API-data namespace, we are establishing a clear boundary for other modules to interact with our entity. They should never access the database directly or use our model classes, only these interfaces. Remember, in Magento, interfaces aren't just for developers to understand the code, they are actively used by the dependency injection system to determine which classes to instantiate. Let's create a new file at API-blog post repository interface PHP. This file will be placed in the API directory, not in API-data, because it's a service interface, not an entity interface. This repository interface is the gateway to our domain model. It defines a comprehensive CRUD API that follows Magento's best practices. Let's explore each method and its significance. The save method handles both creating new blog posts and updating existing ones. Accepts a blog post interface object, enforcing type safety. Will throw specific exceptions if the operation fails, allowing consumers to handle errors gracefully. Returns the saved entity with any database generated values like IDs or timestamps. The getBid method provides direct access to a single entity when you know its ID. Throws no such entity exception when the requested entity doesn't exist. This exception pattern is consistent throughout Magento, making error handling predictable. The getList method. This is the powerhouse method that powers our admin grid and any filtered collections. Takes a search criteria interface parameter that can contain. Filters field equals, greater than, contains, etc. Sorting instructions which fields ascending, descending. Pagination page size and current page. Returns a specialized search results object with metadata about total counts. The delete and deletebid methods provide two convenient ways to remove entities. Follow Magento's pattern of returning Boolean success and using exceptions for failures. The deletebid method combines lookup and deletion in one operation. Notice how we're using Magento's standard exception interfaces in our PHP doc comments. This creates a consistent error handling experience across all Magento modules. Now that we've defined our interfaces, let's implement the repository. This is where the actual business logic for CRUD operations will live. Let me now implement the actual repository class that fulfills our interface contract. Let me explain what's happening in this implementation. 1. We start by implementing the blog post repository interface and including all necessary dependencies through constructor injection. 2. The save method uses our resource model to persist the blog post to the database. Notice the try-catch block that converts any database errors into Magento-specific exceptions with helpful messages. 3. The getPid method creates a new blog post model, loads it with data from the database using the resource model, and checks if it exists before returning it. 4. The other methods would follow similar patterns. For example, getList would use the search criteria to filter and sort our collection, while delete would remove records from the database. 5. By using factory classes like blog post factory, we're following Magento's dependency injection pattern, which makes our code more testable and maintainable. The repository pattern provides several benefits. 1. It centralizes CRUD operations in one place. 2. It provides a consistent API for working with our models. 3. It allows for dependency injection and better testability. 4. It follows Magento best practices for extensibility. Now that we understand all the components, let's see how data flows through the system when we perform CRUD operations. This diagram shows the path data takes from the controller or UI component all the way to the database and back. When we save a blog post, for example, 1. The controller or UI component calls the repository's save method. 2. The repository calls methods on the model. 3. The model uses the resource model to interact with the database. This structured flow ensures that each component has a single responsibility. This flowchart gives us a more detailed view of how data moves through the system. We can see that 1. The process starts with the controller or UI component calling the repository. 2. The repository works with the model to set data. 3. The model passes that data to the resource model. 4. The resource model executes the actual database operations. 5. The data then flows back up through the chain. Understanding this flow is crucial for working with Magento's data layer effectively. Now that we understand the flow of data, let's see how we can use our repository to perform CRUD operations in practical code examples. These examples show how you would use the repository in a controller, block, or other class where you need to work with blog post data. First, let's look at how to create a new blog post. This example demonstrates how to create a new blog post. Let me explain the key steps. 1. First, we use the blog post factory to create a new empty model instance. This factory was injected via the constructor using Magento's dependency injection. 2. Next, we use the setter methods that we defined in our interface to populate the model with data. Each setter corresponds to a field in our database table. 3. Finally, we call the repository's save method, which persists our model to the database. Behind the scenes, this uses the resource model we created earlier. This same pattern works whether we're creating a blog post from a form submission, an API call, or a data fixture. To retrieve a blog post by ID. Here, we're using the repository's getPid method to load a specific blog post. 1. We call getBid with the primary key value we want to retrieve. 2. The repository uses the resource model to load the data from the database. 3. If the blog post is found, we get back a fully populated model instance. If not, the repository throws a nosage entity exception. 4. Once we have the model, we can access its data using the getter methods defined in our interface to update an existing blog post. Updating a blog post is straightforward. 1. First, we typically retrieve the existing blog post using getBid not shown in this snippet. 2. Then we modify the model using the appropriate setter methods. Here we are updating just the title, but we could change multiple properties. 3. Finally, we call the repository's save method again. The repository knows this is an existing entity because it has an ID, so it performs an update instead of an insert. This consistent API means we don't need different methods for create and update operations to delete a blog post. The repository provides 2 ways to delete a blog post. 1. The delete method accepts a model instance. This is useful when you already have the model loaded and want to delete it. 2. The deleteBit method accepts just the ID. This is more efficient when you only know the ID and don't need to load the model first. Both methods ensure the database record is properly removed. And finally, to get a list of blog posts with filters. This example shows how to retrieve multiple blog posts with filtering. 1. We use the search criteria builder to create a search criteria object. This is Magento's way of encapsulating filtering, sorting, and pagination logic. 2. We add a filter to only get blog posts with status =1 published. We could add multiple filters, sorting rules, and pagination parameters. 3. We call the repository's getList method with our search criteria. 4. The result is a searchResults object containing the matched blog posts. We can iterate through them using getItems. This pattern is particularly important for our admin grid as it provides a consistent way to filter and sort our data. This demonstrates the power of our model architecture. We can easily perform all the necessary operations on our blog posts using a clean, consistent API that follows Magento best practices. The repository pattern gives us a standardized way to work with our data while maintaining separation of concerns. Finally, to connect our interfaces with their implementations, we need to configure Magento's dependency injection system. Let's create a file at etidxml. This DXML file is crucial for Magento's dependency injection system. It tells Magento which concrete classes to use when someone requests an interface. Notice that we need to add both interfaces to the DXML file. 1. The first preference maps our blog post repository interface to the blog post repository implementation we just created. This is essential for any code that wants to perform CRUD operations on our blog posts. 2. The second preference maps our blog post interface to our concrete blog post model class. This ensures the repository can work with the correct model implementation. It's important to include both of these preferences in your DXML file. If either one is missing, you'll get errors when Magento tries to inject these dependencies. With these preferences set up, whenever any code requests these interfaces through constructor injection, Magento will automatically provide our concrete implementations. This is a key part of Magento's service contracts approach. Today, we've learned how to create the model, resource model, and collection classes for our Magento 2 admin grid module. We've also implemented the repository pattern for clean CRUD operations. In the next lesson, we'll create the admin grid UI component which will display our blog posts in the Magento admin panel. We'll set up columns, filters, sorting, and pagination. Thank you for watching, and I'll see you in the next lesson. If you found this video helpful, please like and subscribe for more Magento 2 development tutorials. Leave a comment if you have any questions, and I'll do my best to answer them. See you in lesson 4.